Now let's continue here. This is the third case when we have the magnet placed like this. The north is on the left and the south is on the right, okay? And it's moving away from the wire, from the coil. So you can see here, those magnetic field lines go into the south, right? And then out of the north. So at first it's nearer to the coil, so you can see we have like 3 of them or like even 5 of them, right? Kind of like sent through the area, the cross-section area here of the coil. But when it's moving away, then there will be less of them sent through the coil, right? So now you can see initially B1 should be in this direction, right? Because that the direction of the magnetic field lies over there, right? This will be the B1, the initial one. Then we can see that later it's moving away. There are less magnetic field lines sent through. So it means that less flux and also like less of the strength of the magnetic field. Okay. And also like the same direction like this, right? So in order for from initially this one but then result in this one, oh, then we should have a decrease, right? So what should be the change, right? The vector change in magnetic field. I could say this is the amount of magnetic field change, right? And it should be in the opposite direction. So we can see that to more accurate, it should be like this. Oops, sorry, my bad, it's here. Okay, so it should be like, oh my gosh, what happened? Sorry. So it should be this amount, right? If we have this this vector, right? Sum with this vector, right? You can see that we place the tail of this one to the head of the initial vector, right? Then we would result in the later vector, in the final vector. So I could move it to the other side here for us to easier to see it. So let me move it again here. Okay, this one here, right? Then we can see this should be the resultant vector. Make sense? This is the head of this one. Oops. This is the head of the first vector plus with the place at the tail of the second vector. Then the resultant vector should go from the tail of the first vector to the head of the second vector. So this is the final one. Okay, just like last time when we did this one. And now again, the induced should be against the change in the flux. So that's why this is the change in the flux. So then the induced should be in the opposite direction. Okay, this is the B induced. Okay, and then again, as the B induced in this way and also the magnetic field of the source also in this way, you can see that they point in the same direction. So that's the case when you have the flux decreasing, then the induced will be poised in the same direction with the original vector. Okay, but it's always opposite to the change. Okay. So now again, if we got this one, the induced this way, then just apply the right hand rule again. This will be in the thumb direction. Then you try put your hands in, right? Then you can see that your other finger should wrap around like this, right? So that's why we got the current this way, right? And that's why you can see that there will be a current going this way, this way, this way, this way, this way around the wire. So that's why the needle turns around like this. It's just like in the first example. Okay, so you can see the difference, right? The south and the north in this way is opposite to this way, and this one also the moving toward this is also moving away. So seems like there are two opposite things happening here, and then the result is the same. Make sense? Okay, and then finally, okay, you want to try this one yourself? Let's take it slow then. Now we got north here, south here, moving towards right. Okay, so north and south, okay, on the magnetic field line going to the south, out of the north, okay. First it's further away from the coil, then later it got nearer. So first less magnetic field, later more magnetic field, right? More magnetic field lines, so more flux. So flux increasing. Then the delta change will be a positive, right? Then now what is the initial? Okay, the initial is this way, right? This is B1. The final is longer, B2. Okay, I read. Then we can see that in order for B1 to become B2, we should sum it with an amount delta change in the same direction, right? So I could put it this way to make it more logical, right? We got from this one to this one, add a little bit more, then we got more in the end, okay? So it should be like this. This makes more sense this way, right? Okay, then we have the induced should be opposite direction with the change, right? This is the change. This should be opposite direction with the change. Then this is the B induced. This is the B induced. And the B induced actually also opposite to the original magnetic field of the source, right? Okay, so if the B induced this way, now just the right hand rule again, the B would point in the direction of the thumb, and then, right, you see that your hand should wrap around this way, right? This is how you can have your hand on the right hand rule. Okay, so that means that your your thumb should be this way. So that's why you can see that, oh, okay, it go this way, right? It go this way. It go this way around. Okay. So see, you can see that the current flip the direction once again. All makes sense, right? Okay, and for this one, the before and the after, because the magnet is just like inside the coil, so just assume that all the magnetic field line is being sent through the area. So when it's just still moving inside the coil, it's nothing changed, right? Still the same number of magnetic field lines, that's why it's still the same flux, so then the change in the flux is just like 0. And if this one is 0, then the electromotive force is also 0. There's no current, okay? There's no current at all, okay? So constant, no change, no induction, and no current. Okay, sounds good. So not too much for the whole topic D4, right? Just basically remember these key formula. This one depends on 3 variable, okay? And this one, the Lenz's law against, or if you want to identify the induced current direction, you need to start with the B induced first, okay? And the B induced always in the opposite direction with the delta change in B, okay? So when you got the B, the flux, if you got the flux is increasing, okay, then you should have the B induced against that increasing. So in that case, it should like opposed to the original, right? But if you got this one is decreasing, then you should got the B induced support the original one just like to push it up again, okay, to bring it up to the original level. That's why it's somewhere against the change. Make sense, right? Okay, so that's everything for the induction. And please let me know if you still have question or anything not very unclear yet. Just let me know. Thank you. Good luck.